Hello, and welcome to the DecentraWise Podcast. My name is Pedro.
And I'm Miguel, and you just joined us in our mission to decentralize the world wisely.
Wisely, very important keywords to us all. And today we have an interesting episode because we will talk about zero knowledge. And if you don't have any knowledge, like zero knowledge of like buttons, it's that like button over there that you can press, and you can share this video with your friends as well. If you don't know, I can prove it to you with the zero knowledge proof. That is a good thing to do. And
And don't forget to subscribe, of course, because you will like to receive notifications for all our videos in the future. So don't forget to subscribe.
yeah, and if you don't subscribe, I zero knowledge proof to you that you did it wrong.
I didn't even.
That's it, guys. It's the episode. Goodbye.
Yeah, see you next week, guys. See you in the next one. Okay. So let's start. After you guys like and subscribe, of course, we can start talking about what the hell is zero knowledge proof. And so, yeah, do you want to start with that?
Yeah. Zero knowledge proofs are a cryptographic way of proving to someone that we know something without revealing what something is.
Yeah, well, yeah, just keep going.
Yeah. So this seems obvious, right? Zero knowledge proofs. It seems obvious, but it's not that obvious when you try to do it, really, right? Because to provide information that unequivocally shows that you know something without revealing what you know, it's kind of hard. If you think how hard it is to play those games, those guessing games, where you need to tell someone something without speaking, or with your hands, or by mimicking, or by drawing, even drawing, which is something that people do quite a lot. It is very hard without drawing the thing, right? Or drawing letters saying what the thing is, right? So, because usually we are not Dalis or.
Yeah, speak for yourself.
Of course, you are. I know that you have paintings in Louvre.
Yeah, I even have a pencil here so that I can draw some stuff. So yeah,
and you are able to write with your left hand.
And I'm able to zero proof you that I'm Dali.
Okay, do it. Let's.
No,
I won't.
no, actually, I'm able to prove you zero that I'm Dali. So.
Proof zero.
I'm not.
I am able to prove zero a lot usually.
Okay, so yeah, let's try to give some analogy of how this thing works, because usually in cryptography you just sign something which actually is handing some information that you probably don't want to hand out, because the signature itself might be a piece in, well, maybe not now, but probably in the future with computer advancement, might be a piece of decoding your keys. So you are handing some information that you probably don't have to, at least not with zero proof. You don't have to supply any additional information on
One very
that.
important thing in zero knowledge proofs is to grab your coffee, sit back,
Yep.
and relax. Because usually this shit takes time. So you have to relax a bit.
Yeah, so it will get nerdy for sure, like always. So yeah, let's just get some try to simplify things and
Let's
give
yeah,
give an
let's
analogy.
give the
Maybe a couple of
easiest
them.
the easiest way to think about the zero knowledge proof is an hash. It's not technically a zero knowledge proof, but it can be can help thinking about it, right? If I want to prove to Miguel that I have a file with me, Miguel can ask me, create an hash of the file and send it to me, so that I understand and so that I know that you have the file, right? Of course, this is not technically correct in the zero knowledge proof
Yeah.
in its own, because Miguel had to have the file to be able to compute the hash to verify it.
Yeah.
So that's the problem, right? But it's easier for us to reason about, right? An hash is a cryptographic function that starts from an entity and computes a value, a small value that unequivocally belongs or is created off of that entity, right? So anyone knowing the entity is able to verify that you know, right?
Mm-hmm.
That problem is that knowing the entity, which is the missing piece for a zero knowledge proof. A zero knowledge proof means that the verifier is able to verify without knowing the source that you know the source and you have access to it, right? So it's the next level of hashing and cryptography in general, right?
Yeah, actually, I have a couple of really nice analogies that I just found funny, but they are really good descriptors of what we are talking about here. So let's talk about the first one, saying that I'm claiming that I have the best pizza recipe, but I don't want to give out the pizza recipe. So I just come to you and say, well, I have the best recipe for pizza. And you say, well, prove it. And I make a pizza for you. And you eat it and you taste it, and it tastes like the best pizza in the world. Right. And you say, well, that's fine. Do it again. And I just bake another pizza following my recipe. I'm not giving you the recipe. I'm just baking the pizza. And you are tasting it again. This tastes like the best pizza in the world. Do it again. And I do it like 30 times.
I like that. I like that proof.
Yeah, it's a good one. It's a good one.
Especially if I can do it in every meal.
Yeah.
A month.
I would say that I had the best burger recipe, but I would miss the punchline at the end. So wait up. So after 30 times,
so it only works for one piece of information, not two.
Yeah, well, it works for pizza because, well, wait for
pizza.
the punchline. Okay. And after 30 times, you taste it, and it tastes like the best pizza in the world. So you hand to me that, okay, you have the recipe for the best pizza in the world. And you grant to me that I have the proof. So it's proven. And it's also proven that you get fat. So it wouldn't work for burgers. So that's so that's why. So here's the thing. I proved to you that I had the for 30 times, and it might
or
differ
three
on the
thousand.
amount. Yeah, it might differ on the amount of the accuracy that you want to have, of reliability that you want to have. Uh, so I proved to you 30 times that I had the recipe for the best pizza in the world, and you verified it. So
Yeah,
that's kind of how it works.
usually the
And I didn't give you
verifier.
the recipe. Yeah, and I didn't
Yeah.
give you the recipe.
So the
So
piece of information that was not supposed to be shared was the recipe
yeah,
of the pizza. Uh, by iterating over and over again, the prover and the verifier, which is something that we also need to explain here. The prover is the one that wants to prove, right? It's Miguel in this case. And I am the verifier. So I am eating loads of pizza to verify that Miguel knows how to do it, right? So uh, I had access to the best pizza in the world in one of my trips, and Miguel claims to know the recipe, and I want him to prove to me. So I make him bake 3,000 pizzas in a row, and he was able to do it. So in my risk assessment, I think that okay, 3,000 times it's enough. I am fed up with pizzas. I don't want to eat the best pizza in the world anymore, and I accept that he have proved um, that he knows the recipe for me. So this is the story, right? Um, this is an iterative process, right? Which is one of the types of zero knowledge proofs. There are more. So uh, there are a few other examples that are classical, right? It's the cave, the example of the cave where um, the verifier stays at the entrance of the cave, and the cave has channels like this in the door at the back, and a rock in the middle, so there's no way to get around it. Uh, and the verifier asks the prover to prove that he has the key to the door, right? And without showing the key or opening the door for him. So what he wants is for him to prove. And the way to prove is to go from one side and appear on the other side and do it again and again and again so that the verifier, as Miguel did before with pizzas, the verifier would feel comfortable accepting that the proofer was able to open the door. Okay? Because sometimes the door might be open already. So you have to do it several times to know for sure that he has the key. The other classic example of zero knowledge proofs is the colorblind man with the green and the red balls. Um, for him, the balls are equal. He doesn't see the difference of colors, and he wants the prover to prove to him that the balls are effectively different. So how do we do this, right? The verifier holds the balls in his hands and puts
come on, this is YouTube.
not
They're going to
not those
cancel us.
balls, not those balls.
We
Okay.
are going to be canceled
Um,
because of that. Yeah, just keep
so
going.
one ball is red, one ball is green. Those balls are both red, so
Thank God
they're
they're
not
not blue
enough.
balls.
They are not enough. He puts the balls behind his back, and he shows one to the prover, and then puts it back again and shows another ball, which might be the same, or he might have exchanged the ball. And he asks the prover to tell if he exchanged or not. And doing that many times, he is able to verify that actually the balls are different. For him, they seem equal, but for the other people, he knows when he changes the ball or not.
Yeah.
So these are the classic examples of zero knowledge proofs. And if you check online, there are thousands of
Yeah.
them. So
Yeah. Let me give you a real life example of that. When you call to your bank, you start talking to the operator, and the operator wants to verify that it's really you, that the owner of the account that is calling. So what they request from you is the call is diverted into a machine which asks you for a pin, for a key. You insert the key with your keyboard so that the operator never sees you inserting the key. And the computer says it's verified or not. It's okay or not okay. So that is a real life example, so that the operator then just gets, well, it's okay, so it's verified.
yeah, but
And
that requires a
that is very
third party.
similar.
It's a
Yeah,
different
but yeah, well, it's
mechanism.
the same, but it's the same example as the caveman that has to open a door. So the third party is the key lock in that door. So it's the same, and it's well, I think it's the only real life example that I have right now, because it's not very used. They try to make other banking institutions try to make like, well, just tell me your email, your birth date, and whatever. But those are and they just verify, and the computer says, well, it's okay or not okay. But those are all public, already public information, so it's not that useful. And so this one that I said, that it diverts the call to a machine which will verify the pin, it's more of a zero proof knowledge than they just asking you for information.
Zero knowledge proof is of course, in that case, it's zero knowledge from the perspective of the operator. But
Yeah. It's
the
always
system
in
has
the cave.
to have the
Yeah, in the
information.
cave. Well, in the cave example, just imagining that the key is it's a pin, that it's a key lock that you have to insert a pin. It will be zero knowledge, but the key lock, the pin lock, will be the third party that you are talking
Yeah.
about. The same is with the key, right? With the physical key.
Yeah, but the beauty of zero knowledge proofs is not requiring even a third party. It's just information going around and being able to verify that actually you know without any third party. It's just so trivial for the validator, for the verifier, that it doesn't need any support from any system or any third party. But anyway, so this is what we have been talking about is an iterative process, right? So it requires several times to repeat the process so that the verifier feels comfortable with the result.
Yeah,
Right?
it's easy to
It's
explain
like
that with
statistical thing, right?
yeah, it's easy to explain that with the daltonic guy, with the colorblind guy.
Mhm.
So you have 50% chance to get it right. But if you reiterate the experience like 30 times, you just have to multiply 50% by 50% by 50% 30 times. So
Yeah.
the chance that you get it right by chance is
It's getting
very,
smaller
very
and
close.
smaller and
Yeah, it's
smaller.
very, really close to zero. It's insignificant. So for you, it is actually proof that it's right. It's impossible, it's statistically impossible to be wrong. So
Yeah. So it's
that's why
usually
you iterate the experience several times, and the
yeah.
more times you repeat the experience, the more reliable it gets.
This iterative process is usually done to real life, real situations like physical situations because you don't have any other alternative. But in the digital world, thankfully, we are able to do a lot of this shit mathematically, not
Yeah.
by iterating back and forward and so on, but doing calculations, right? And that is why zero knowledge proofs are interesting in the digital world and for digital money or anything like that. It's that we are able to create proofs that actually uh, are able to verify quite large amounts of information very fast. And it's usually very hard to compute the proof, but it's very easy to verify. The complexity is completely um, uh, different, right? On the side of the proof, generating the proof, and the side of the verification, right? And that is uh, why zero knowledge proofs are very interesting for this kind of applications, right? So uh, one of the most talked types of zero knowledge proofs is ZK snarks. Uh, ZK snarks are actually snark is an acronym. So zero knowledge, ZK, zero knowledge, and snark means succinct, non-iterative arguments of knowledge, right? So
Yeah, what is that?
it is a proof, a way to compute a proof that you know something, zero knowledge proof, without that iterative process. So it's a succinct, it's very small
Mhm.
in size because you could do that, but it would generate a terabyte of information, and moving it around is not that cool, right? It
Mhm.
takes forever. So it's very important to be able to reduce the size of the proof so that it's actually feasible to use, right? And non-interactive because it doesn't require that process of back and forth a million times to reduce risk uh, and increase certainty in the proof, right? So uh, that's why ZK snarks are that cool and are talked about in many situations around blockchain, right?
How, do you have did you checked how is that implemented in a blockchain, and what is really replacing with these new zero proof blockchains?
Um, It's mostly used in rollups, right? Because um, when you have, in the case of layer 2 scaling, right, you have uh, two ways of doing scalability networks, like layer 2s or 3s or whatever. You can do it, you have several ways, but the most common are having an isolated network, right? And you have a bridge between the two, and that's it. Or you can have a network that actually settles a proof of its state on the main chain. So, what does that bring to the table? Because having a different network is sufficient, right? Or no?
I don't
If
know.
you have, if
Keep
you have
going.
another, if you have another network, um, the problem that you have, and you have it in the layers, in the layer 2s, they are all going in the ZK rollup uh, uh, way, exactly because of lack of decentralization. Uh, what does this mean? If you have, we launched many networks, and we participated in many networks launched by other people, um, and most of the times shit happens, right?
Yeah, yeah. Well,
uh,
that's a
because
given. Yeah.
networks are not decentralized enough, and usually people are greedy, and they start manipulating or doing business with the networks or whatever, and then you see a chain being taken over, for instance, or whatever. There's a lot of examples. I I could go on and on talking about this kind of situation, but one of the situations that is very dear to my heart is Steam. And in case of Steam, it was one of the first DPoS blockchains with 21 active validators in network at any given time. And it wasn't enough, or it wasn't decentralized enough, because the company behind the creation of the Steam blockchain, which was Steemit, they decided to sell it. How can you sell something that is decentralized? Uh, so they sold the Steemit Inc. And they controlled a bunch of tokens. And the guy that actually bought Steemit Inc. was Justin Sun uh, from Trump, and from he owns an exchange as well. It's I think Poloniex. I don't know.
Very poor guy, I'm sure.
Yeah, he is very poor, and he is very much loved by some people and hated by a lot more, me included. I don't like the guy, but anyway, I bet he wouldn't like me if he knew me. So we are good. But he bought Steam blockchain, and it was not decentralized enough, and he was able to take over the chain by controlling the majority of validators. And it was an example. It was not a bad example because it was an example of the ability of proof of stake chains to actually fork. And when it tried to take over the chain, the validators that were kept aside because he had a very big pool, he could vote in his own validators, right? The validators that were put aside, they just forked the chain and created another one, which is Hive. It's still ongoing today, and it was a proof of the resilience of DPoS chains. But it was a proof as well that if the distribution of tokens is not well done, there is a level of trust that is very significant, right? And a level of risk for the participators in the network, right? And that is one example of these problems that chains usually have with decentralization. Of course, if someone controls a very large chunk of the stake in the network, that person can invalidate transactions, right?
Mm-hmm.
They can change history. And it's something that is not supposed to happen, right? That's why.
Yeah, well, it's not a very good blockchain if it does that.
That's why Bitcoin is proof of work, and it's the most secure network in the planet, right?
Mm-hmm.
Because it's impossible to change it. It would require much more capital to change it, a single transaction, than probably a million transactions together would provide for the thief or the abuser of the network, right? So that's the reason why proof of work is very important, because it's very decentralized. It's very hard to manipulate. And when you have a proof of stake blockchain, what matters is the stake, not economic power outside of the network. You see the difference? Because if your network is, the economic power of your network is created by you, it's a token created out of thin air, the holder can mint a bunch of tokens for himself and control the network, right? And in proof of work, no. There is no one able to do that because it requires external economic value to compute blocks, right? There's no one able to compute blocks without significant costs in energy.
Yeah.
Right.
What would happen if Bitcoin moved to zero knowledge? I mean, there are implementations. There are implementations.
Zero knowledge requires always a place to settle. It's not that you can move just by itself, by yourself. For instance, Ethereum, because I don't know any ZK based rollup for Bitcoin. They are coming, I think, but not yet. But for instance, in Ethereum, you have Binance Smart Chain, right?
Mm-hmm.
Do you think Binance Smart Chain is decentralized?
Well, no, not really.
Who controls BNB?
Well, Binance.
Right? They say that the validators in the network are a group of companies, blah, 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 whatever. who control the stake, who controls the stake in the chain controls the network, and Binance
Mhm.
has the biggest chunk of BNB
Yep.
for sure. So um, most probably uh, that chain is a, requires a very high level of trust from people participating in the network in Binance. I, I'm not saying that Binance is bad. Actually, I have very high respect for CZ. He is a very early guy in this space of an OG, and actually, I think he always did uh, what was in the best interest of this industry. Uh,
Yeah.
Even in the FTX case and all that, he was one of the guys saying, "Guys, that is a problematic thing."
Yeah.
Um, there's questions about going public with that information
Yeah, well,
and so on.
I
But
mean,
well,
I have mixed feelings about the guy also. And the thing is, in my opinion, he's doing what he thinks is best for the ecosystem. And well, we've been seeing Binance having some issues with regarding compliance and stuff like that. But we need to figure that, and we need to acknowledge that Binance is here for some years now,
yeah,
where nothing was compliant with anything, and they were actually once the most compliant around the world.
and one thing that I always remind people when saying Binance is a bad guy, a bad actor in this space, and then so on. Binance created a lot of things that are very important in this space nowadays. Safu is one of them. It was the first exchange to have a secure um, some kind of level of security for bad things happening.
Mhm.
It was the first one. There was nothing in the industry like that. Uh, Another thing, um, they had problems and they never uh, had any user losing funds. They always paid back from Safu uh,
Mhm.
all the problems that they had, all the hacks, and so on. So that is very important. Also, proof of reserves was the first exchange to launch proof of reserves. Now everybody does. So this is very important, right? This is an industry that is growing and with a very high level of uncertainty because nobody knows how politicians will
Well,
try to
no,
regulate this shit,
yeah,
right?
nobody
So
knows what's going to happen tomorrow, and
yeah,
every day
so
we are seeing stuff that we just, what the hell are they doing?
yeah, so
They're
this
trying
is
to
the thing.
regulate so badly.
This is the thing. I think Binance is a good player exactly because of that. They are uh, trying to do good things with a very high level of uncertainty. And of course, they are the bad guys for Americans because they are Chinese,
Yeah, well,
right?
and they will have, of course,
Because
their interests.
FTX, which was American, was a very good exchange, right? Uh, and now they point the fingers at Binance. So yeah, that's. But yeah, this is another discussion.
Yeah,
Let's go
that's
back
another episode.
to
Yeah, well, I was asking this because there are other blockchains that implemented ZK, so we can talk
yeah, and I
about
think
Zcash, we can talk about Monero, and they implemented
But
a ZK
that's for
algorithm
another
or
reason.
an evolution of
That's
a
for
ZK.
another reason.
Yeah, and
That
I
is,
wanted to. I was asking that. So, what happens, and where I was trying to get is the impact. For once, the impact that it would have on the economic system of the blockchain, and on the other hand, I would like to ask where ZK is used to do. What is it used for?
for instance, in chains like Zcash or Monero, um, zero knowledge proofs are used for validating transactions without knowing the transactions themselves, right? So that is
So
the
it's
reality. But
replacing
but
the
that's
signing algorithm, right?
uh, not exactly. It's much more complicated than that because usually in those chains, even computing your own balance of your own account is complicated, right? Uh,
Mhm.
because there is no information about your balance anywhere, right?
Yeah.
Um, Usually, uh, your account is just like um, a holder of generated, um, cryptographically generated blind addresses, right? So those addresses will hold funds for you, but nobody knows that they belong to you, not even you, if you don't have uh, record of those addresses. So nothing is stored on chain, and so on. And let, let's not go too deep on how that is implemented because it's very very complicated. But the idea of that is that you are able to uh, prove that you are you without revealing yourself. For instance, to sign a transaction in a blockchain, you have to compute a signature and provide your public key. Because
Mhm.
someone to verify that needs to verify that signature requires the public key to verify the signature, right?
Yeah.
And to create the signature, it requires the private key belonging to that public key, right? This is the mechanism. Uh, so, if you would use signatures in blockchains like Monero, every transaction would be signed by your public key, so everyone knew that was you, right? It was
Yep.
not private at all, right? So
Yeah.
the trick is to compute a proof that you are you without a signature that requires your public key, right?
Mhm.
That's the idea. And also to create those stealth addresses and to create ring signatures and all those things. Yeah, it's a lot of technologies, not just zero knowledge proofs that are used on those chains. But for instance, we were talking about layer twos. So Binance Smart Chain is one layer two, one totally separated network with a bridge in between, which is called Binance, right?
Mhm.
So if you want to transfer funds to Binance Smart Chain, you go to Binance, send Ethereum in, or they have some kind of bridging, easy bridging without logging in to your account. But they do the bridging, right? They are the
Yep.
ones controlling the bridge, right? So, and the network is validated by a group of people that they chose, and that's it. So there is a very high level of trust in that network and in those validators that they wouldn't change your transactions, right? Because they can. Okay, don't think they can't, because you are being naive.
Yeah.
They can, and they probably won't do it because Binance doesn't want to, because Binance is not controlled by Sam Bankman-Fried of sorts. He is fried because he's in jail. He was freed. Now he's fried.
Yeah,
And
he was freed before getting arrested.
exactly. So, too bad for. But actually, people will get their money back. That's a good thing about FTX.
Really?
They will get 110% after Bitcoin multiplied its value by 3 or something, 4.
Yeah.
They will get 110%, I think. Not bad,
Well,
but
not good at all.
far away from being optimal. Anyway, you could have lost it all in some meme coin, so you never know.
Yeah.
Anyway, so example of Binance, example of any other chain, for instance, crypto.com, Chronos. It's another example. It's a federated network. It's not something that is decentralized, right? That's why they are going for ZK rollups as well, with ZKVM chain, right? So what does that mean, really? That means that that network might be controlled by the stake of some nasty operators. Could be, just imagining, right? Usually they are not nasty, but just imagine that one of them
Yeah,
was a
well,
very
if they get nasty,
terrible
they will lose
guy, like
credibility,
Miguel.
right?
One of was a very terrible guy, like Miguel.
Yeah.
And
With the recipe for the best pizza in the world,
and he
that
wanted
will get
to,
you fat.
yeah. So that guy wanted to change some transaction, right? When he is able to produce a block, he could mysteriously change something, and colluding with the half of the network, he would be able to do it, right? So $1 billion transaction, he would divide it in 5 or 6 pieces, distribute to the other guys on the other validators, and they would create the majority of the chain, and the rest of the chain would have to agree with them. And business as usual, no one knows. And this happens, right? Not by this reason, but it's usual for the network to have forks and to come to a consensus again. It's called Byzantine fault tolerance, right? It's not fault avoidance, because it's impossible, right? But it's Byzantine fault tolerance, and it happens usually in networks, right? It can be caused by many things, but this could happen. What ZK rollups do is they store proofs on a higher security chain. So let's, in this case, in this example, it's Ethereum. Ethereum is decentralized enough for us to feel safe using it, right? That's why I hold
Mhm.
funds in Bitcoin blockchain, Ethereum blockchain, and nothing else. I don't hold any funds Doge. I also I am a degen. I have some Dogecoin.
You have meme
Um,
coins.
no, Dogecoin is not a meme coin.
Ah, it is.
Dogecoin is the meme coin. Yeah,
Yeah.
fuck the others. Dogecoin is the meme coin, and I
Now
have to
there's
do.
one.
I
Now
even
there's
have a
one
node.
called.
I even have a Dogecoin node. I am mining Dogecoin.
Now there's one. There's one called Crow with a knife. Have you seen that one?
No,
It,
I'm not that.
I've seen it in Twitter. So it's always a crow with a knife in the beak, like this, grabbing a knife. Just funny.
Well, so imagining that a layer two wants to inherit the security of a higher security network like Ethereum, right? What they do is with a certain um, uh, regularity, they compute proofs of their state, and they store them on Ethereum, right? So, what does this represent? Uh, this represents that it's impossible to change transactions after they have been proven to the main chain that that was the real state of the chain, right? In the eventuality of a fork could never go back in time before the last proof submitted to the main network,
Okay.
right? Does that make sense?
Yeah, well, it's kind of a security feature there because they cannot fork beyond, well, beyond to the back
Or roll back?
from there. Yeah.
Yeah. So that's the idea of rollups is to inherit the security of the base chain and be able to safely uh, live with less secure networks, knowing that they are less secure, but using the advantages of those networks, which by being less secure, they are less costly. Usually they have faster transaction times because
Less fees, of course.
exactly. So that's the point. It's to create a way to have a less decentralized network being almost as reliable as a very secure network with all the scalability
Yeah.
trilemma against it, right?
Yeah.
That's the thing. So ZK rollups are like that, and usually they use ZK SNARKs, ZK STARKs as proofs, uh, something like that, right? ZK STARKs are a newer technology which is easier to verify, but it's more computation incentive in creating. And yeah, um, so ZK rollups are like that. They just compute their a proof of their state and
Mm-hmm.
store
And
it
pop
on
it up
chain.
on the main chain.
Yeah.
Yeah. So you mean that when using ZK, the network gets less secure?
It is less secure. but that's a proof that we know that it's less secure. That's why we require to store a proof on another chain, right? That is more secure.
Yeah, but
Right?
it's less secure because of rollbacks, right?
And there are several mechanisms for rollups. And now that we are talking about it, we have optimistic rollups and we have zero knowledge rollups, right? Chains like Optimism are, as the name indicates, right?
They're
Optimistic rollups.
optimistic. Yeah.
They are optimistic rollups. So, what does that mean? It's the other way. The other way of looking at this transaction, right? Imagining that there is a layer 2 settling on the layer 1, right? Either you use very hard to compute algorithms like ZK SNARKs or ZK STARKs to compute the proof, so that it is that a verifier is able to verify it on the fly, right?
Mm-hmm.
It's very computation intensive, and it's
you were
hard.
saying incentive for a while.
Yeah. I was.
Yeah.
I am able to be dyslexic from time to time, especially in English. Yeah. But yeah, I can do worse than that. Don't worry. So,
well, before you were grabbing the balls, so the incentive is fine.
Whatever. So you have that way to prove, which is easy to prove, because it's usually faster to verify. So imagining a bridge or something like that to take funds back to the main chain, they would have to verify that the transaction is already settled, right? And it's valid, and it's accepted to be valid. So before releasing the funds on the main chain, right? So by using a zero knowledge proof, you are able to verify that actually, yeah, that is the correct state, and I can be assured that nobody is fleeing with the money, right? And the optimistic rollups, like Optimism and other chains, use the opposite methods. So it's that supposition of innocence before proven guilty, and ZK rollups are the opposite. So you have to prove unequivocally that you are not guilty, so that people can trust you because you proved it, right? In the optimistic rollups, they assume that everybody is a good actor until proven wrong. And there are incentivization mechanisms for people to prove wrong transactions, right? So instead of having the computation, the hard to compute requirement all the time for every settlement, they usually settle without any proof. They just settle an easy computation of the state and require the provers of something faulty to do the computation to prove that a transaction is invalid, in fact. So it's interesting, but the problem of this alternative is that provers need time to prove. right?
Yeah. Well, yeah.
So that's why usually on that kind of chain, if you want to take funds out, it requires a bunch of time, like a week or even more, to take your funds out, right? Because there's a time delay between the request that you place and the assurance of the network that all the transactions are valid and impossible to change, because there's a certain amount of time that people have to prove that those transactions are invalid, so that they can create the necessary proof of invalidity of those transactions. So that's usually the two mechanisms of rollups, and what they bring to the table. Let's imagine. I actually think that Binance is working on a ZK
Yeah, I guess so. I
as
think I heard
well.
something. Yeah.
So, what does that bring to the table? In fact, right, is that you don't have to trust Binance. You are able to verify. Period. And not even Binance will be able to change the state of the chain, even holding all the funds, right? Because they would require to compute, to change the proofs of the network on the main chain. And since the settlement is done and is irreversible on the main chain, on Ethereum in this case, they are not able to do it, right? So they will be able to do damage just for a very small amount of transactions that are still to be settled on the main chain. That's it. This imagining that the entity controlling the layer 2, we are talking about Binance, but we can say the same thing as for Polygon or for any other layer 2, actually, right? Any layer 2 that is not a rollup or was not a rollup, they can do whatever they want because they are a lot less decentralized than something like Ethereum or Bitcoin, right? So this is why rollups are a very interesting thing, and why we should care as developers to use those technologies, right?
Mm-hmm. Yeah. So, what other uses can we expect to see in the future for all of the Web3? Because we talked about blockchains, but we should be able to use ZK for other things like authentication stuff, and we don't quite see that much.
Well, one area that is getting traction is the identity. We talked about it in the few episodes before, in the sense that all the information about your identity or related to your identity are stored on chain only for you, not accessible. It's stored encrypted, not accessible to anyone, right? And people endorse, create. It's not endorsements, but it's something like that. I don't remember the word. For you, for instance, real entities like your university, they create your certificates on chain, and it's encrypted for you. So they encrypt it with with your public key or something on, or some other methods, and they sign it so that you can verify that they actually issued that endorsement, and it's stored on chain, but only you have access to it. Nobody else has access. So what you can do then is, or what the projects are trying to implement or trying to provide, is a way for you to make a proof without revealing the endorsements. So they are claims. There are claims, right? And those claims require you, for instance, to be older than 18. One example, right?
Yeah.
And you don't want to reveal your age,
your age. Yeah.
right? But you can create a proof that you are older than 18, right? Or a claim that you have a university degree. You don't want to tell which degree, from which university, right? But you can prove that you have higher education or something like that, right?
Yeah.
This is just one example. We are humans. We can find utility for a bunch of shit, and I bet we will for this kind of technology, because it's very interesting.
Yeah, it is.
So,
And I'm expecting to see some developments in this area using ZK. I think blockchain was kind of the first to take that step, but I think we will see more of that in the Web3 space pretty soon. But I was figuring where that could be applied, and why the hell it's not yet. I know this is kind of new technologies, despite it's, I don't know, from the 80s or whatever.
yeah.
But it's taking traction right now. But it's like cryptography. Cryptography is quite old. Not these new algorithms, but in essence,
this is cutting edge.
Really old.
This is cutting edge technology from the 70s.
Yeah.
And 80s. But
so
just
it's
imagine,
50 years old. Yeah.
Just imagine, we were talking in this podcast in one of the first episodes about lack of interconnection between email providers and features from the 80s or 90s, like GPG, right? And actually, Apple released an update having integrated with email encryption this year.
They were listening. Your city was listening to you.
Probably Tim Cook is a listener in our podcast.
I think it's city.
It's city, maybe. But this takes ages. People never, still today, they don't see the point of encrypting emails.
Yeah, well, Right.
And but they want to send letters in envelopes. They don't send letters without an envelope, but they send emails.
Yeah, well, it doesn't go encrypted, right? People don't know how to encrypt stuff, so they
They
don't understand
people
what's the
don't.
purpose of it.
Yeah. So yeah, this is the point. Technology for encrypting emails is available. It's free. It's not used because people don't fucking care, right?
Yeah.
And blockchain cares because there's money involved, right?
Yeah,
And
yeah. Well,
usually
of course,
a
they
bunch
will
of
have to
money.
grasp to the 10% that do care.
That's why we are cutting edge because we are creating an industry around cryptography, which is something that exists for ages, uh,
Mhm.
even before computers, right?
Yeah, well, I think it comes
And
from First World War. I think
and
that they started to
it
really
was never
implementing some
used
cryptographic
in
stuff.
a larger scale because people just don't give a shit
Yeah,
about their privacy and their freedoms and their uh, secrecy of information. They
yeah.
just don't give a shit. So this is why this space is so cool because we are able to put this to work for the
Hmm.
first time
Yeah.
and see that it actually makes a difference, right? Because
Well, it's making a difference. People just need to realize what's the impact, because most of this stuff is like under layer, and people don't see it. But yeah, well, if people are using blockchain, uh, everything goes through encryption algorithms, but people don't really care if they go through those algorithms to make it safe. They just know that it's safe, and that's it.
and they know because they the people controlling the thing they said to him to them, right?
Yeah, people
Like
and people even use crypto, and they don't realize it's cryptographic stuff. They
like
don't know that they are talking about cryptographic stuff.
people are
It's not
getting
about
used
coins.
to this reality, and then they use WhatsApp, and because WhatsApp says it's encrypted end to end, they believe it,
Yeah, right.
and
Yeah,
then they get their chats uh, handed over to the police, and they are in jail because they were talking about nasty stuff the next day.
yeah. Well, go figure. But
And
WhatsApp, it's what? It's Microsoft.
yeah,
Yeah,
but it's the same with Telegram. It's the same with anything. Just if you want encryption, go to Matrix. Don't
yeah,
go to Signal because Signal is also a company behind it.
yeah,
Matrix is free, open source, and you can run your own node and
yeah. Exactly.
have a truly private.
Decentralized and the private communication system. Yeah,
So, but people just don't give a fuck. They don't understand and they don't want to understand, and that's it. And
yeah,
the only way to solve this is the way crypto is doing things. We do it, and people use it because they have to, because otherwise they can go to use the legacy system,
yeah.
and that's it.
Yeah, well, they can, because the legacy system seems to be planned to go away, right?
Plan to go away. This usually takes ages.
Yeah, well,
It's
we
not
will see.
it's
There
not
are some
tomorrow.
things that I'm figuring that will be really fast, like having your own physical money, right? Because even though that you are using the legacy system, it's not physical money. You are just making electronic transactions. But the physical money, I think it will be kind of easy to get rid of, and it will be quick. That's my
I'm not sure.
prediction.
I'm not
Yeah,
Nostradamus,
that's my prediction with my crystal ball.
but you have a crystal ball. I don't, so
Yeah,
that's why I cannot predict the future.
yeah, I can borrow
Anyway,
you my crystal ball one of these days, so that you can see.
okay, done.
Yeah, but I think I truly hope not. I wouldn't like to get rid of physical money. I think it's really important to have it. But yeah, we will see.
We will see. We will see if we reach an all-time high, as my shirt says, all-time high, soon as well. If you can
Yeah,
check on your crystal ball, that would be awesome.
yeah. Well, I will check it later. It will probably be at the end of the next year. So
Plenty of time to buy.
yeah,
DCA, guys. DCA is the magical keyword.
exactly.
Dollar cost average, in and out.
Yeah.
Uh, don't do it out right now. Not
now
financial
it's
advice.
now it's the time to get in. Yeah.
Don't do it the other way around. As Raul Paul says, don't fuck this up. Right?
Yeah, it's well, yeah. Have you noticed that? Well, the increases in value of Bitcoin have been decreasing. What I'm saying is that every time we have a halving and then all time high, the percentage that it increases is now getting shorter and shorter. So
That's
yeah, it's the way to go.
natural.
Yeah, so it's because it's getting also less volatile, and it will get more and more stable with time. So yeah, you won't get like 2000% like in the previous bull runs, unfortunately,
Good
because yeah, well,
times.
yeah, those were
Good
the times.
times.
But
But anyway,
yeah, yeah, I think we're up.
well,
Do you want to say
yeah.
anything else about CK?
I think we are good to go. We covered a lot of stuff here.
Yeah,
Um, I don't have in my notes any other. If you guys have any questions,
yeah.
uh,
Feel free
put
to
it
ask. And
put them in the
there,
comments.
yeah, there is something that I forgot to say. If you guys enjoyed this content, please like, subscribe, and don't forget to share. Our content is very useful for the people that find it useful, of course. And if you have a friend that you would like to share our content with this person, please do. It will help us a lot on growing on YouTube. And yeah, so that's what I had to say. Do you want to
Yeah.
say anything else?
Also, join our social networks. We have a Telegram group. You can check
Very
on our
important.
website.
Yeah.
Uh,
You can ask us
usually,
questions there, and we will try to answer
yeah,
as soon as we
usually
can.
people are asking stuff there, and we are always doing our best to reply to all of those things. So,
They're very
also
cool people.
suggestion for other
Yeah.
episodes.
And by the way, thanks to Alfredo for suggesting this topic. We try to keep as real as possible. Uh, so yeah, you guys can also suggest topics that you want to hear us talk about, and doubts that you had during this episode. You can also post a question there, and we
Yeah,
will try to answer as effectively as possible.
exactly, guys. So this is it about zero knowledge and zero knowledge proofs and rollups and all that nasty stuff, and ZK snarks and starks and
Yeah,
farts and
yeah.
um,
it was nerdy as usual. So guys, yeah, that's why we say at the beginning it will get nerdy because it usually gets.
actually it just got to my mind, another proof of another example of zero knowledge proof.
Yeah, what?
A fart.
Come on. ZK fart.
Okay, guys, this is getting
No,
out of
this
control.
is the end. This is the
This
end.
is getting out of control. We better leave while we can. So, hope you enjoyed. If you need to have any more detail, ask around. We will do our best to do to help you out.
Yeah.
And thanks for joining us in our mission to decentralize the world wisely. Or not so much. Like
yeah.
At the end,
like
of
today was
the episode,
was not that much.
Anyway, guys.
Well, guys,
see you around. Cheers.
see you in the next one, guys.
Bye bye.